All right, today's lesson is about instantaneous rates of change, velocity and acceleration. The process you already know because it's basically derivatives. It's more of the terminology. So anytime you see the word instantaneous, that tells you you are going to be taking a derivative. Maybe help if I spelled it right. So anytime you see the word instantaneous, that means derivatives. And the long way is what they're talking about some of the time. They'll let you know which way. Yeah. But this is our derivative formula. So this is going to be, anytime you see instantaneous, this is the process they're going to ask you to deal with. Now, they're going to talk about velocity, but first we're going to have a distance formula. And that distance formula is some s that equals f of t. So our function will be in terms of time. So we'll have a distance formula in terms of time. So the velocity, v, is really the first derivative. In other words, of this function, whatever it is, you take the first derivative, that is the velocity. Now speed, and again we'll have word problems here, is going to be the absolute value of the velocity function. Sometimes notation-wise, they'll say d sub x over d sub t. Now when we talk about it, when we talk about the first derivative, a lot of times we call it d sub y over d sub x. In other words, the change of the equation of y's in terms of x's. That's why that x is on the bottom. Now, acceleration, the acceleration in time is the derivative of the velocity function, or the distance, it is the second derivative. So if you have the distance and they want to know the velocity, you take the first derivative. If they want to know the acceleration, you take the second derivative. If they tell you what at so much time, you just substitute in for your t and you'll have your answers. And then make sure you label them meters, meters per second squared. Now there is a fourth one that's kind of wild, and it's called a jerk. And I mean mathematically, if you go look in the book, that's what they call it. And it is called j sub t, and it is the derivative of the acceleration, or the second derivative of the velocity, or the third derivative of the distance. So, can you see that once we have our equation set here, we can find all of this information fairly quick. Okay? Now, they're also going to tell you about average rate of change. Average rate of change and instantaneous rate of change are not the same. Here, if you notice, there is no limit. So you'll have an answer that has h in it. So when you ask to find the average rate of change, there is no limit. You will have an answer that will deal with an h in it. All right, I need to go to the next page because I need more room. They're also going to talk about displacement. And displacement is basically the change in our distance formula, and it's equal to f of t plus delta t minus, basically they're going to give you an equation, they're going to have a delta, it's like x and y here, but again this is basically the numerator of your slope formula. Because then when they ask you to deal with average velocity, and we'll just use v of an upper little a v, this is basically your slope formula. But again, there is no limit on this, So you'll end up with probably a delta t as part of your final answer. All right, most of this unit so far in this section is basically terminology. The actual process you can deal with. So they're going to give you, they're going to talk about a cost of production. And remember, eventually we're going to do lots of applications. We'll call it some C of X. If you see the word marginal, anytime they ask for marginal, that's the derivative. So if in the process they ask you to find the marginal cost of production, basically they're asking you to find the derivative. All right, questions? Turn it off.